Hello guys, welcome to my channel, and here I'm in front of you with new video. And here you can see we have the treadmill card, and the brand is Precore, and its model is old model if you are familiar with Precore. And it's a DC motor based treadmill, and here you can see the two terminals for the motor connections, the positive, the red one and black one. So it's it's a DC, and here we have the two wires. And first I'm going to give you the overview of this card. And here we have the alternating current in and alternating current, these two terminals for alternating current. These terminals are for your inclined motor. So most of the treadmill cards or most of the electronics you have, you have seen that the manufacturer or the electronics engineer use the relays to latch the circuit, like since it's the inclined motor is either 220 volt or 110 volts, so they use the relays. But in this case we have the trikes to switching of alternating currents. So here we have two, one for the up and second for down. And this is I did not see such kind of thing in any other treadmill. Here we have the circuit breaker, safety circuit breaker, and here we connect the circuit breaker wires over here. So if there is malfunctioning, and if this card draw more amperes than rated, or if there is any like a problem in the circuit, it sends 12 volt signal to the circuit breaker, and circuit breaker breaks the power, or you can in a short word says it discontinue the supply of power. So it's a safety circuit breaker, but it is based on internal signal. So the 12 volt signal is used to either break or make this circuit. So, and here we have the port for speed sensor, and this is the for speed sensor. And here we have the port for the fan, and here we have the communication, because it's RJ45 connector, and the wire connected from this port to your upper console. And here we have the lift port. That means you connect your incline sensor over here. So whenever you have to repair such kind of cards, be careful, because it has very big capacitors, and they are enough for you to give you a fit or excellent shock. So be careful, okay? So first of all, and the problem is and this card is it's not getting powered up. So if you supply the power over here, it's not getting the powered up. I have already checked, and it's not getting the powered up. Someone already tried to fix this, and here we have someone tried to deposit some glue over it, but I don't know why. But let it probe in a more specific manner. And in this Precore card, actually the power is converted through this module. So it's a semicron module, that's skip 13L something, and we will pull it out, and we will see what's the number of this module, and we will remove these screws, and then we will remove this. Remember that if you are going to remove these Allen keys by using this metric L keys, so you wouldn't be able to open this, because the sizes of these screws are in inches. So you have the Allen key set in inches size. So first let me remove this, and then we will go through it a more specific manner. Okay, I have removed this module. Here we have the module, and it's not only the motor driver, and it has the bridge circuit which converts the alternating current into DC current, and its number is semicron 13NEL0631. So it's used to drive the DC motor, and also converts the alternating current into the DC current. Then it then the converted current is reach over in the over these capacitors, and here we have the high frequency transformer which converts the high DC voltages into step downs the voltages. And here if you can see, here we have the IC which is number, it's if you can see, it's top 204YI, and I have checked this, and it's short. I have already checked it, and let me pull it out, and then we will confirm it, because sometime you scan the components by using your multimeter, and it gets and it give you the continuity or some ambiguity. So what you have to do, you have to pull it out to confirm, because sometimes there are too many other components that could be short, and the component which install in the line of that IC or any component, so it could be shortage of any other thing. So I'm not 100% confident that this component is short, but since it's giving me the continuity, I will pull it out and I will check, and then we can say. But the shortage could be due to these diodes. So this is the diode, and too many other components. There could be possible reasons, but first we will have to remove this IC, and it's the power IC of this card. So I have pulled it out, this IC. It's top 204YAI, and here I have the multimeter. I have placed this multimeter on continuity, and here you can see, and so this is short. So this is short component, and it and here I have another IC which is, I hope it's good. So let's check this. It's good. You can see it's fine. And if I reverse the direction, and if I was placed this like this, and if I reverse the direction, like if I change the continuity, so then you can see it's the value of diode. So this one is good, and this is short. So I will replace this IC, and then we will see the behavior of that card. Okay, I have replaced this IC, and even also I replaced these two optocouplers, that's CNF, because it was giving me a knocking sound. So, and here you can see the light is up, powered up. So it's mean that this card has been fixed, and now it will, since the problem was the power, and now I hope that it will powered up. So since I have this light is powered up, it's our light of power, so it's mean it's working fine. So we will install this card into the machine and then see. Thank you very much for watching this video.